Okay, so 1 and 3, we're going to have 1, which is 4x plus 3y plus z equals negative 4. So there's equation 1. Okay, good. And equation 3, negative 2x plus 4y plus z equals negative 7. Okay, so in this one, let's make some space. In this one, we need to eliminate x again. I want to make sure we understand what's going on here. So we're starting out with three equations, and we want to turn three equations with three variables. We want to shrink that down into two equations with two variables. So see, this only has two variables, y and z only. Okay, so I want to do the same thing here. I want to get another equation that's y and z only. Okay, so because I destroyed or eliminated x here, I have to destroy or eliminate x here as well. Everything, the first set is in terms of y and z now. I need this to be in terms of y and z as well, so that I can work out my two system of equations with y and z only. So I need to destroy x. So to do that, I have a positive 4 and I have a negative 2. Now I need these to cancel out and they don't. If you do 4, take away 2, you're going to get 2. And that's not 0. I need 0. So what can I do to negative 2? Okay, to make it so that these cancel out.
Multiply
Yeah.
by
Say again. I'm
multiply
sorry.
multiply by 2.
Yeah, multiply by 2. If we multiply this one by 2, I'm going to have 4 and negative 4, which are going to cancel out. Okay, so I had to multiply the one with negative 2 in the x by 2. So I have to multiply this bottom one here by 2. Okay, so I'm going to multiply this by 2. So let me just copy the top one because I'm not doing anything to this one. I'm just going to leave it alone. It's 4x plus 3y plus z equals negative 4. So I'm not doing anything to this. I just copy what I have. Now this one I'm multiplying by 2. All right, so this should work out great. If we do 2 times negative 2x, we're going to get negative 4x. And that's good news. I need that because I need these to cancel, and they're going to now. I have to multiply the entire thing, though. So 2 times 4y is 8y, and 2 times z is 2z. And then 2 times negative 7 is negative 14. So that's everything multiplied out. So that looks great. Um, then from here, right now we can cancel some stuff out. Okay, we're going to get what we want. We're going to get the 4x and negative 4x are going to wipe out. We needed that to happen. We can put the 8y and 3y together for 11y, right? 8y and 3y is 11y. And we could put 2z plus 1z together for 3z. And then we can put negative 14 and negative 4 together, and that's going to be negative 18. So look what's happened now. I'm down to two variables. I'm down to y and z only, right? This one's y and z, and this one's y and z. So now what we've done is we converted a system of three equations with three variables, x, y, z, into a new system of equations, one equation here, and only two variables, y and z only. So I can work this out. This becomes easy now. 3y plus 4z equals 11, and 11y plus 3z equals negative 18. Okay, so now I'm down to a system of equations with two equations and two variables, which we know how to solve. This is like algebra 1 stuff now. Okay, so we can solve this pretty easily. You're going to need to select a variable to work with. You could either choose z or y. It's your choice, but you have to get the variables to wipe out. So somebody want to make a selection, we can either destroy Y or we could destroy X. And when I say destroy, I mean eliminate. We could eliminate Y or we can eliminate Y or eliminate Z, excuse me. So I could choose to eliminate Y or I could choose to eliminate Z. So somebody want to select one and then we'll eliminate the selected variable. There is no right or wrong. It's kind of up to you as to which one you want to work out. The work is even in this one. It doesn't really matter. So I'll let somebody select. So somebody select something. We could either take away, try to work out the Y values or the Z values to make them eliminate.
Y.
Okay. So let's get rid of Y. So currently Y is, this is just my side work here. So currently Y is 3 for one and 11 for the other. So if we're trying to eliminate Y, obviously 3 and 11, they don't eliminate, they make 14, right? So I need to find something that 3 and 11 could both become. What number could 3 and 11 both become? Anybody have any ideas that we could use multiplication to
33.
find? Yeah, 33. 33 is the best thing I can think of. So to get 11 to 33, I'm going to multiply by 3. And to get 3 to 33, I'll multiply by 11. And there is a problem with what I did. Right now, these are both 33, which is good. But I need one to be positive and one to be negative. Otherwise, they won't eliminate. So I'm going to make one of these guys negative. I'll make this 3 negative. And it doesn't matter. If I make this negative 3, now I have 11 times negative 3, which is negative 33. And here I have 11 times 3, which is positive 33. And we know that 33 and negative 33 are going to eliminate each other. All right. So what I did was I multiplied the one with 3 by 11. Let's multiply this one with 3 by 11. And we multiplied the one with 11 by negative 3. So this is a little bit of work because we got to multiply both of them. So let's do one at a time. We can do 11 times 3y, which is 33y. And then we can do 11 times 4z, which is 44z. And then 11 times 11 is 121. So we're okay there. Down here, we have negative 3 times 11, which is negative 33y, which is very helpful. Then negative 3 times positive 3z, that's negative 9z. Okay, we're looking good. And then negative 11 times negative 18. Well, two negatives make a positive, and negative 18 times negative 3 looks like that's going to be 54. Okay, that looks good. All right, so that's everything worked out. Now we're going to get what we wanted. We're going to get the 33y and negative 33y to cancel out, so that's good. We eliminated a variable. If we put 44z minus 9z, I believe that's 35z. Right, 44 minus 9 is 35. And over here, 121 plus 54 is 165. And then to get z by itself, just divide 35 on each side of the equation, which will eliminate, we'll cancel that out. And then 165 divided by 35. I believe that's, did I make a mistake? Oh, that's why, my fault. A little mistake there. I was wondering what was going on there. 121 plus 54 is not 165, it's 175. Okay, all right. So 175 divided by 35, that's 5. Okay, so great. We got one of the variables. In my opinion, once you find one of the variables, the problem is really easy because the other ones are just easy to find. It's finding the first variable that's always tough. and we found that z is 5, and if we check, right, we saw that z was 5. So I know I'm doing it right. I did it by calculator with the class. We did it on Friday using Desmos matrix. So now we're doing it mechanically. So this is correct. So z is 5. Once you find z, the problem's super easy. You can just pick one of the equations, either this one or this one, to find y. If you pick this one, you'll find y. If you pick this one, you'll find y. It doesn't matter. I'll pick the top one. It's up to you. 3y plus 4z is 11. So if we're choosing the top one, 3y plus 4z equals 11. Well, we know that z is 5, so just put that in there. 3y plus 4. I'm going to put 5 in there. Equals 11. So I just do the multiplication here, and that's, again, because I'm just replacing 5, I'm just placing it into z, right? If you wanted to put it in this one, you could. I promise you, you'll get the same value for y anyway. It's up to you. 3y plus, so I replaced the z with 5. This should be 20. And then from here, you're just solving the equation for y. You can subtract 20 off of each side. In doing that, you're going to get 11 minus 20, which is negative 9. So these canceled out. 11 minus 20 is negative 9. And to get y by itself, we're just going to divide by 3. Cancel those out. And negative 9 divided by 3 is negative 3. So I know y is negative 3. And let me just check to make sure that I got the same answer on Friday when we did this question in class. So y is negative 3. And y is negative 3. All right, x should be 0. Let's make sure x is 0. So we got our z value, we got our y value. We just need our x value next. Okay, to find x, well, I need an equation with x in it. And I don't see anything here. So I'm going to go back just to the very beginning and just find one with x in it. And this will do. 4x plus 3y plus z is negative 4. Yes, you could choose 2. Yes, you could choose 3. It's your choice, but I'm just going to choose the top one. It doesn't matter. 4x plus 3y plus z is negative 4. 4x plus 3y plus z is negative 4. So I'll choose the top one. And I know that z is 5 and y is negative 3. So I know that y can be replaced with negative 3. And z can be replaced with 5. Okay, so I just replaced y with negative 3 and z with 5. And now I work this out. Positive 3 times negative 3. I multiply these, I'm going to get negative 9. Okay, I just multiplied these and got negative 9. And then if I put negative 9 and 5 together, because they're on the same side of the equation, negative 9 plus 5 is negative 4. And I'm trying to get 4x by itself so I can solve for x. So I'm going to add 4 to each side of the equation. And that's going to allow these to cancel out. And now I can say 4x equals, well, I know that negative 4 and positive 4 make 0. So that equals 0. And finally, to get x all by itself, I can divide by 4 on each side of the equation. And if I divide 0 by 4, I still have 0 because that doesn't change anything. 0 over 4 is 0. So I know x is 0 now. And I knew that already because I did it by the computer and we saw that x was 0. So everything that we did now algebraically matches what we did in the computer on Friday when we used Desmos to do it. So we see that the two answers are the same, as they should be, of course. And you might be wondering, hey, well, Casey, why do I have to do all this? You know, look at all this work here. just to get these three values, which on Friday we did this in like 2 minutes, right? I can just put the augmented matrix in, let the computer do the work for me, and I'm good. Well, that's great. And one of the questions on the exam will be multiple choice, like this one, and then you just use the augmented matrix. There's no point in doing any of this work over here. However, there's a second question on there that is in the back of the exam, which says you have to show an algebraic solution. So with that question, right, you're going to have no choice but to go through all this. And I know that just can't be helped. I would still use the computer to get the answer. So at least you know whether or not you did it correctly. All right. So you'll know if you did it right or not before you start doing the algebra. You'll know what the answers are because you can use the computer to get them. But but we have to go through this process, unfortunately, to solve. Now, be careful. I'm not sure if the one on the back of the exam, it might be one of the questions where there's no solution or infinitely many solutions, right? So then the computer can't really help you in that sense, right? Those you have to just work out. You won't get what you're supposed to get in terms of the zeros and the ones when you use the computer. So just be careful, be mindful of that. We saw examples like that in the homework too, so it's not anything new. Are there any questions on this before I go on to the other example? Because I only really have like two things to look at today. This was one thing, and I know this is kind of a lot. This problem is pretty long. There's a lot to do, but if you stay or fairly try to stay as organized as possible, and it makes it a little easier. The main thing, in my view, the tough part is getting these. Okay, once you get the two equations, you get this and you get this, then it's not very hard anymore. It just becomes a question like you would see in Algebra 1, where you're working out, a system of equations with two variables, which is not that hard. So it's just getting from here to these two. That's the tough part. After that, it's not really much. And then you're just doing a bunch of back substitution to find out the missing values, which is just substituting numbers in. There's not really a lot of labor after that point. Any questions on anything here on this one? All right, I'm assuming then that making the assumption here that we're pretty good then with this thus far. So if that's the case, I'm going to flip to the back, the example I didn't do yesterday, and we'll handle that now. Okay, so this question was the last one on the sheet that I posted, but we didn't get to finish this one yet. And it's fairly similar to a question you did previously. I'll read it, we'll go through it, and then I'll put the essential formulas that we can use to work with this. You can kind of reason your way through this problem without any formulas, though. If you care to do that, you could. Okay, it's kind of like a problem you could figure out just by deduction when you read the example. The table below represents the number of hours a student worked and the amount of money that the student earned. So we can see if they work for 8 hours, they earn $50. If they work for 15 hours, they earn 93.75. For 19 hours, 118.75, and for 30 hours, $187.50. So we can see as we work more and more hours, the money we earn is increasing, and that should make sense to you, right? Most jobs you have like an hourly rate, so basically you work for whatever your hourly rate is, you just multiply the number of hours by the hourly rate. Um, I'm going to give you an example just to make life easy here. So, for example, say you took a job that paid $10 an hour just to make the math easy. So that would mean that what you earn, your D, would be 10 times H, right? For every hour you work, you make $10. So, for example, if you worked only 1 hour, which I don't know who would do that, but if you worked only 1 hour, you would make $10, right? If you worked, let's say you worked 15 hours, all right, that's going to be 150, right? If et cetera, you can keep doing this, right? So you simply multiply the number of hours you work by the rate that you earn, and that tells you how much money you made. And if you were to model that in the coordinate plane, okay, if you were to model that in the coordinate plane, it just looks like this. Okay. Basically, if you work, not draw off the scale, so 1 hours is $10, right? 2 hours is $20, right? 3 hours, and et cetera. And you can make a line. It's just a linear function. Okay. So it's just a linear function. All right. For every time you work an hour, $10 gets added on. So 3 hours is $30, 4 is 40, et cetera. This line just keeps going up. Okay. And it's the same thing here, just that the hourly rate is different in the problem that I gave you here. So you're gonna have to try to figure out the hourly rate on your own. And there's a couple of ways of doing it. You can just nearly divide by the money you make by the hours that you work. That'll do the job. But they're hinting at they want you to do it through a linear function model. Personally, I don't care. Any way you get it is fine with me. But I know what they're hinting at here. They want us to write an equation that represents the number of dollars D earned and the number of hours H worked. That's part A. And then part B, use the equation to determine the number of dollars a student would earn working 40 hours. All right, because part B, 40 hours is not on the chart. So you just want to figure out how much they'd make, right? How much they make if they worked 40 hours. So you have to figure out what that salary, what that amount would be. Obviously, it's going to be bigger than 187.50 because if you work 30 hours, you make this. If you work 40, it's got to be a bit more. All right. So that's kind of just reasoning through the problem. What they really want from you, because this model is going to be a line, okay, it's really just y equals mx plus b. Okay, and the hourly rate, if you notice the number in front of h, that's really the slope. That's the rate of change. So m, we know that m is equal to y2 minus y1 over x2 minus x1. Okay, and this is kind of this is how it is when you're actually working, right? The slope is your hourly rate if you're looking at it in a context like this question, right? For every hour you work, your salary goes up by your hourly rate. In this case, m is your hourly rate. So you work more hours. In my little trivial example here, for every extra hour you work, you make an additional $10. So in my example, m is 10. Okay, that's your hourly rate. So every time you add on another hour, you make an additional $10. And that's in my fictional example here. Okay. That's not the case here. I'm not sure what the hourly rate is. They want us to figure it out. So we'll figure it out. Just know that in this question, y, okay, the number of hours is acting as x, and the amount earned is acting as y, right? Because the money you make depends on the number of hours you work. So y is the money that you make, and it depends on x, the hours you work, okay? Which in this case is h. So if you want to change it to make it match what they have here, you could say d equals mh, okay? The dollars you make is equal to whatever your hourly pay is times the hours you work. Okay. Plus B in this case, there is no if you don't work at all, I don't think you get anything in this problem. So B is 0. But you don't have to worry about that. I'll show you that B is 0 when we do the example. All right. Any questions so far? Anything? We're okay? All right. I'm assuming we're okay because it's not
Yes.
really. Oh, great, great. It's not really too much here. So you need to figure out the slope, and it's your choice. You need 2 points. Okay. You need 2 points to do this. Somebody want to select? So for example, 8 comma 50 is 1 point. 15 comma 93.75 is another point. 19 comma 118.75 is a point, and 30 comma 187.50 is a point. So there are 4 points given here. Okay. If you were to plot this in the coordinate plane, which we could do, you'll see you have 4 different coordinates. So to use this formula here, I need any two, it doesn't matter. So somebody want to pick 2 coordinates for me?
First point and the second one.
Okay, that's what I picked in my other class too. So good choice. So we're going to pick, so if we're picking these, so we'll make This can be x1 then. This is an x value. This can be x1. This would be y1. This can be x2. And then this can be y2. Okay? So x1, y1, x2, y2. Do you have to pick these? No. You could pick something else. You could have picked point 1 and point 3 or point 1 and point 4 or 3 and 4. Any way you want to do it. You need any 2 points will do. So since we chose 1 and points 1 and 2, these two, so I'm going to do y2 minus y1. So y2 minus y1 is 93.75 is y2 minus y1, which is 50. Divided by x2 minus x1. So x2 is 15 and x1 is 8. So I got to do $93.75 minus $50. What is that? That's $43.75. Divided by 15 minus 8, which is 7. So if we do 43.75 divided by 7, let's just take care of that really quick. I think it's 625. 43.75. Oops, I made a mistake. Divided by 7, I believe it's 625, so I was right. So it's 625. 6.25. Okay, that M, that's his hourly rate. So basically, this person, the dollars they make is equal to 6.25 times H. Okay, so this person's salary is $6.25 per hour. So every time he works an hour, he makes this money. So we could check this. If we put 30 in here, 6.25 times 30 is going to give you 187.50. If you put 19 hours in here, 6.25 times 19 should be 118.75, like it states here. Okay. So that's his salary. If you want to figure out what he makes, you just put the number of hours he works in for H, and that'll give you D. And the reason you can do this is because you're earning 6.25 an hour. So just multiply the amount of money you earn per hour times the number of hours you work, and you have the salary. And that's pretty easy. So D, they just want the equation to be placed here. I'll place it here. D is 6.25H. Okay, so there it is. I'm just copying it here. All right, simple as that. That's it for part A. For part B, using the equation, determine the number of dollars the student would earn from working 40 hours. So if that's the case, if I want to know how much he earns for working 40 hours, all I have to do is put 40 in there, right? If I want to know how much he earns after 50 hours, I put 50 in there. If I want to know how much he earns after, 80 hours of work, I would just put 80 in there. So however many hours he works, I drop that in for H, and that'll give me D. So in this case, D is 6.25 times, 40. So I got to do 6.25 times 40. And I have 250 for that. So the amount of money he's going to make if he works 40 hours is 250 bucks. Okay? And that seems to make sense. Okay? After 30 hours, he's making 187.50. So 40 hours, 250. And that seems about right. Okay? That seems about right. And that's basically it for this example. Um, Again, this problem I thought was easier to do by hand, but if you wanted to use the calculator, you could. All right, you could. You could have the computer do the equation for you. So let me just show you that because I have like 8 or 9 minutes left. I'll show you how you could use Desmos because you can use Desmos. I don't think it's worth it here though. I think this problem is easier or easy enough that I would probably just do it this way. There's not a lot going on here. Just finding the slope and then plugging that in, and that's really it. It might be more work to actually put all this information into the computer, but I'll show it to you anyway. So if you want to use Desmos, you can. So to use Desmos, let's go in to Desmos. And now I hope I don't make a mistake here, but let me see. Okay, so to use Desmos, I'm gonna have to put a table in here. So this is a little confusing. It's hard. Like I said, I think doing this one manually is better. If I want to do this, I can put a table. The little plus sign allows me to create a table. And then I have to list my values. I have to look back. It was 8, 15, 19, and 30 for the hours. So 8, 8, 15, 19, and 30 were my hours. 8, 15, 19, 30. Let me make sure I did that right. 8, 15, 19, 30. And then $50, 93.75, 50, 93.75. Make it the other two values. 118.75 and 187.50. 118.75 and what was it? 187.50. They just check to make sure they're making no mistakes. And that looks good. Everything looks good. So that's the data that was in the table that we saw. I just copied the data and I put it in a table in Desmos because I have to let Desmos know my table value. And now I want to write a equation of a line using this information. So this part's annoying. It's y, I believe, and then I put my data in what in sub one. So y sub one, and then is approximately. Oops, I think it's this one. And then I have to do. I'm writing the equation of a line, so it's mx plus b. So m x sub one because it went in sub one. And I can probably get away without writing the plus b. It's not going to matter because it doesn't matter here. I can get away with it, I believe. Let me see if I put it in what happens. Yeah, it doesn't make a difference because b is 0. Okay, so if you put the whole thing in, you're still good. So m is 6.25, the same as I have, right? 6.25, and b is 0, which I knew because if you don't work at all, you're not going to make any money. So b is 0. So yeah, so here's the equation. You could just rewrite this as y equals 6.25x plus 0, or y equals 6.25x. I don't think it was worth using technology for this example. I think the technology is more involved than actually just doing it manually. This is the one rare case where doing it by hand is probably easier. Every other case, technology was easier. So this is the exception. And then once you have this, they ask you how much you make for working, what is it, 40 hours? So I can just scroll over to 40, which is like here, and it's, let me zoom out a little further. So 40 was 40, 40. Okay, 40. Let me try to get it. So I could say if you work for 40 hours, right, you're going to make 250. All right, because when age is 40, the output is 250. So if you work 40 hours, you'll make 250 bucks. This is just doing it, with technology, which is fine. But again, my recommendation here is probably just to do it by hand because this problem is easy enough to do by hand. So, but anyway, if you want technology, you can do it. 40, and then if you work 40 hours, you make 250 bucks. So there that is. Let me bring us back to Notebook. Okay, so anyway, we can see that technology will do the job too. All right, if you want, you can do it this way. That's basically it. Okay, that's basically it for today. I know there's a few minutes left. I'll take some questions, but I just want to give you information about tomorrow. So tomorrow, you're going to notice right after this class ends that tomorrow we will not be meeting. It'll be the first day since we started where we don't have a meeting, because you have the assessment tomorrow, and the assessment will be posted tomorrow at around 8:30 in the morning, and it'll be due by 4 p.m. So you have pretty much the day to work on it. I know you have other classes, so that's why I left you time at the end of the day. And also, my class will not happen, so you have the time that you normally meet with me, to work on it. All right. You can use technology. You can do what you have to do. The questions at the back, though, you have to show the work. It tells you when you have to show work. All right. The multiple choice ones, you don't. I mean, you can just use technology for all of it. So let me make sure that I'm going to post that out today. You're going to see that the thing for tomorrow will disappear. It won't be on your calendar anymore because you're working on the exam. So the exam, like I said, gets posted tomorrow at 8:30, and it's due tomorrow by 4. Okay, so like I said, you pretty much have the day to get it done. Any questions on anything? Anything?
Like, how much question is the test gonna have?
14. 14
Okay.
questions. 14 questions. Okay. It's pretty divided. I think there's like seven or eight multiple choice, and then there's it's half and half. It's 50-50. I think it's 8 multiple choice, honestly, and then 6 open response. But one of the open response questions is that long one with solving the 3 variables that I showed you today, right? And that problem's annoying. It takes a while to do. It took me 15 minutes to go through that. So there's a second one, but the second one is in the multiple choice part, and that you use technology for. Okay. And even the one at the back, still use technology to make sure you do it right. So you'll know, I mean, you'll know how you did on this thing because you have technology. You could check every answer. You don't need me to correct it. You can see, okay, this is what it's supposed to be because I can just use the technology and see what the answer should be. So that's basic. That's basically it. All right. I can't post the exam tonight. I can't do that. I have to do it tomorrow. So it'll be posted tomorrow at 8:30, and then it'll be collected. It has to be submitted by 4. All right. Any questions? Anything?
No.
All right. So I'm awesome. So I'm being a little loose with this test. It's really supposed to start when class starts. You have the period to work on it and submit it, but I don't want to do that. I'm doing it this way, so you pretty much have the day to get it done. Okay. So that's it for today. If you have any questions about anything, please send me